Okay, we have here another integral today. We've got the integral from 0 to 1, x squared minus x to the 5th over 1 minus x dx. And of course we could do straightforward methods on it. If you factor, you can get this where you can do power rule on it. I just want to do it a different way. Now, one thing you might notice is with 1 minus x, you could do this using power series, just thinking about creating a 1 over 1 minus x. I don't really want to do it that way either. I think what I want to do on this is use Digamma function. We have a formula where we can kind of reduce this pretty quick. So for the formula I have in mind, over here to the right, we have an integral. It's in this exact form, 0 to 1, 1 minus x. We got some x terms with exponents here. Really, to get this in terms of the Digamma function, we just need to determine our s and z value. So here for the s value, if s equals 3, right, 3 minus 1 is 2, and then the z value on this thing, this is just going to be a 6. So using this part, I can go and write this as Digamma of 6 minus Digamma of 3. Well, that's pretty nice, but then how do we calculate this? Now, we're lucky that it's integers because that simplifies it a lot. We have our reduction formula. We could use the reduction formula. Like for the reduction on Digamma function, if we have z plus 1, we can write this as Digamma of z plus 1 over z. So you could calculate these values individually, especially if you remember like Digamma of 1 is equal to minus Euler-Mascheroni constant. So this is something like minus 0.577 for this value. So you could just calculate each of these to an exact answer and subtract it. You could do it that way. But what I want to do instead is use this formula right here when m and n are going to be integer values. In this formula, the big H is the harmonic number, which we'll go over in a second, but I can reduce for this, you have to reduce the m and n by 1, so we can write this as h sub 5 minus h sub 2. Now for our definition of the harmonic numbers for hn, let me see if I can remember how to do it. This is going to be, I wish I used something else, but this is going to be the sum from k equals 1 to n of 1 over k. So maybe let me come over here. I think I can finish it in this space maybe. So like for h sub 5, using this, we just need to like iterate out these terms. So it's like 1 over 1 plus 1 over 2 plus 1 over 3, 2. Actually, I don't need dot. It's only 5 terms. I think I can write that all the way out. It's not like it's going to infinity. So we're just writing out all the terms to 1/5. And then we have minus for h2, it's going to be 1 over 1 plus 1 over 2, and that's it. So what's going to happen is these first two terms here are going to cancel. And what you could do, just kind of looking at it, you can know that you're starting at 1/3 and counting up to 1/5. So all we're going to need to do is just add up this stuff right here. So I'll just get a common denominator on this. It's all going to be over, like just multiplying everything together, that's 60. To get a common denominator, I need to multiply 4 times 5 on this one. So 20 plus 3 times 5, 15, and 3 times 4, 12 here. And so putting this together for my final solution, we just get 47 over 60, and that's it. Okay, so in most videos, I like to avoid partial fractions, but in this one, we're avoiding power rule for some reason. Okay, that's it for today. Thanks everyone for watching. Have a good day.